Hey everyone, Mr. Skelton here. We are back at it, and then we are in Unit 2. I got some wrong things here, Unit 2, and we are Assignment 2 here. So, if you remember from Unit 1, we did solving systems by graphing, and today we're going to do substitution and elimination. We're going to focus on these two. These are the most commonly used in Algebra 1 and in Algebra 2. Graphing, again, is nice to use, and it's nice when you have your graphing calculator, but it's probably the most inaccurate when drawing or graphing by hand. So let's just jump right into it. We're going to be solving systems. So remember, a system has two unknowns, usually two unknowns, sometimes three, and a lot of our answers today, we're going to have an x equals and a y equals when we solve these, okay? So the first couple examples, I believe, are word problems here, and to be honest with you, I'm going to see if you can set this up on your own. Now, the answer is here so that you can see that, but I want you to read this situation and see if you can come up with the two equations required for this situation to then solve the system either using substitution or elimination. So I'm going to hit pause and see if you can set up two equations from this situation. Okay, so let's read the first sentence. The sum of Gabby's age and twice Ted's age is 39. So obviously I'm going to use G for Gabby, okay, and I'm going to use T for Ted. Those are going to be my two variables. You can use X and Y if you would like to use X and Y. You know, if you said X is Gabby and Y is Ted, I like to use the whatever situation I'm dealing with, people's names, cars and trucks, whatever it is, you like to use those variables. The sum, big word there, sum means add. So we're adding Gabby's age and twice Ted's age. Now twice Ted is going to be written like this. Here's equation 1, G plus twice Ted's. The word is, when you read the word is always means equals, so you can just read it as equals 39. So there's equation number 1. Okay, equation number 2, however, should be a comma there, however, Gabby is 5 less than twice Ted's age. Now a lot of people in Algebra 1 will mess this up when they write this. Gabby equals 5 less than twice Ted's age. That's 2t minus 5. That's how that should be written, okay? So the first part of this is setting up the system to get two equations. Now, how you want to solve this? Well, for my money, anytime you have a variable by itself, like you can see right here I have G equals. Anytime you have a system where the variable is equal to an expression, then I'm going to use substitution. So I would use substitution like this. This is how I do it. I always circle what I'm going to substitute. If G equals this mess, I'm going to plug that mess into G into the second equation. So it's going to look like this. I kind of separate, and now I'm using substitution. So now instead of G, I'm going to write 2t minus 5 plus 2t equals 39. And now I'm going to solve that for t. Put my like terms together, so that gives me 4t minus 5 equals 39. And I'm going to add 5 to both sides. So I should get 4t equals 44. And when I divide by 4, I get t equals 11. Now again, you already have the answer here, which is a good thing, so that you can check to make sure you did it right, which we did. We get 11. And then if you want to find, again, whenever you do a system, there's always going to be usually two answers. Sometimes there's two answers, sometimes there's one answer, sometimes there's no solution. But in this case, we have Gabby and Ted, so I need to plug that back into any one of the originals. You could plug it in here or here. Easier to plug into the second equation, because 2 times 11 would be 22, minus 5 would give you the 17. So that means Gabby has to be 17 years old. Okay? All right, let's flip it over on the back and see what we have here. Got another situation here with Gabby and Ted. A little bit different situation. They went out to eat to celebrate Ted's birthday. Happy birthday, Teddy. Gabby bought 2 tacos and 3 bean burritos for $9.50. Ted bought 4 tacos and 2 bean burritos for $13. How much was each item? Now, again, this is, a lot of people are going to read this and think, oh, I need to use G for Gabby and T for Ted, but look at the question at the very end. How much was each item? So what are we talking about? We're talking about tacos and bean burritos. And so we need to set up our two equations based on the items that were purchased by Gabby and Ted. All right, so I'm going to use T for taco and B for bean burrito. So, and if you want to, I know some teachers will make you say, you know, T equals taco, and B, let B equal the, you know, bean burrito, whatever. I'm okay if you don't have to do that. If you need to write that off to the side to stay organized, go for it. Okay, so we need to set up equations that are related to the situations in terms of the cost that that was the expenses that were out of your pocket based on how much tacos and how many bean burritos you bought. Let's look at the first equation. Gabby bought 2 tacos and 3 bean burritos and spent $9.50. Okay? So for Gabby, 2T plus 3B cost her $9.50. Ted bought 4 tacos and 2 bean burritos, and that was $13. How much did each individual one cost? Well, there's our system. Now, in a situation like this, I would not use substitution. I would probably use elimination. So let's review elimination. Elimination, if you recall, is we want to eliminate or get rid of one of the variables. And we do that by multiplying either the first or second, or sometimes both equations by a number to make the variables cancel each other out or eliminate. So for example, I'm going to, my eyes immediately are drawn to the 4t and 2t, and in my mind, if I can make this a negative 4t, then my negative 4t and 4t would cancel out. So I'm going to multiply the entire top equation by negative 2. So this negative 2 is going to be distributed to all 3 parts of this equation. So when I rewrite my 2 equations, it would look something like this. On the top would be negative 4t minus 6b, right, negative 2 times 3, equals 950. So 950 times a negative 2 is going to give me negative $19. And then the second equation I'm not messing with. I'm just keeping that the same. And now I'm going to add the 2 equations together. Now you may have learned elimination in a different way. This is how I teach in Algebra 1. I get my variables that I want to be eliminated. I get them so that they're opposite of each other. And then I just add all the columns together. So for example, what's negative 4t plus 4t? It's nothing. They are eliminated. What's negative 6b plus 2b? That's a negative 4b. What's negative 19 and 13? That's a negative $6. And to solve for b, I'm going to take my $6, okay, and I'm going to divide that by 4, and that's going to give me $1.50. So b equals $1.50. Again, you have the answer there right in front of you, right here at the bottom. But just to check it, that's how we do it. And again, if you want to find the cost of a taco, now you can take this 150 for b and plug it into either of the original equations. So if I plugged it into the second one, it would be something like this. It would be 4t plus 2, and instead of b, I'm going to write $1.50, and that's equal to $13. And you can solve that. 2 times $1.50 is going to give me $3 equals 13. I'm going to subtract 3. That gives me 4t equaling 10, and I divide by 4, and that's going to give me $2.50 per taco. Okay? All right. At the bottom here, I believe this is the last one. This is only 1 page of notes, which is nice. I have solved using any method. And so the answers are right here at the bottom. I would like you to try these on your own. So go ahead and hit pause. You have the answers right below here. See if you can work both of these out on your own, and then check your answer with the answer provided. Okay, so on the first one, I'm going to definitely use substitution here. Again, whenever I recognize a variable equal to something and it's all by itself, I always circle what I'm going to substitute, and I always draw an arrow where I'm going to substitute it in for. If y equals this mess of 4x minus 7, since y equals it, I'm going to plug that mess into y into the second equation, and it would rewrite something like this. 3x minus 2, and instead of y parentheses, since this is a quantity, 4x minus 7, leave that in parentheses, equals negative 1. Finish out the equation. Now, this negative 2 needs to be distributed all the way through, so that's going to be negative 8x. That's going to be a positive 14 equals negative 1. Negative 5x, I can minus the 14. So I get negative 5x here, like terms, subtract the 14 over, and I get negative 15. And I divide by negative 5, and I should get positive 3. Check. And then I got to plug that back in to get y. So I'd plug that back into the top here. Y equals 4 times x. Now x is 3, so 4 times 3 is 12. 12 minus 7 is 5, so y equals 5. a check. Next one over here. Again, I would probably go ahead and use elimination here. Now, if you look at this, the one we did up here, it was nice because I knew I could just multiply this 2t by a negative 2, and my t's would cancel out right away. Well, if you look down at this one, number 4, there's nothing I can multiply 3 by to get to 5, and vice versa with the 2 and 3 and 5 and 3. So this is a situation where I'm going to have to multiply both equations by a number. Now, my eyes immediately go to the y's because I have a negative 3 and a positive 2. So I know in my mind if I multiply this top equation by a 2 and the bottom equation by a 3, I'm going to have negative 6y and positive 6y, and my y's will cancel out. So remember, common mistake is students don't distribute all 3 parts here. So make sure, I usually draw arrows just to remind myself. And let's rewrite the top equation. That's going to be 10x minus 6y equaling 4. On the bottom we have 9x plus 6y equaling 3 times 24 is going to give me a 72. And then I make a big giant plus sign out in front, and I just add my columns together. 10x plus 9x is 19x. Negative 6y plus 6y, they cancel each other out, hence elimination. Let's get this in the center here, sorry. And then drop my equal sign straight down, and 72 and 4 make a 76. And so 76 divided by 19 should give me 4. So x should equal 4. And the answer's right there, check. And then you got to plug that back into any of the original equations to get 6. So I'll plug it into the top one, so I have 5. Instead of x, I can plug in my 4 minus the 3y equals 2. And that's going to give me 20 minus 3y equaling 2. I'm going to subtract 20 from both sides, and that's going to give me a negative 3y equals negative 18, and divide by negative 3, and I get y equals 6. Check. Okay? So there is our lesson on substitution and elimination. Hopefully when you see those you are able to recall some of those Algebra 1 skills. And if you don't, no worries. We can go over more in class. We can practice more of these. And if you remember how you learned it and you maybe did it a different way than I did, that's fine too. I want to do what works best for you. So let me know if you have questions in class, and I'd be happy to answer those. Okay? Take care.